Restricted. Okay, this is the restricted answer question 9 from the 2015 past paper. It's one of the 3 markers. So this is one of these ones that says, you know, have you got showing good understanding, showing some understanding, or poor understanding. But actually I think this one could be a lot worse. I think it gives you a lot of clues on this one. Occasionally seabirds can become contaminated with hydrocarbons from oil spills. These cause problems for birds because their feathers lose their waterproofing, making the birds susceptible to temperature changes and affecting their buoyancy. If the birds attempt to clean themselves to remove the oil, they may swallow the hydrocarbons, causing damage to their internal organs. Contaminated seabirds can be cleaned by rubbing vegetable oil into their feathers and feet before the birds are rinsed with diluted washing up liquid. Using your knowledge of chemistry, comment on the problems created for seabirds by oil spills and the actions taken to treat them. Right, so for a start we have 2 different parts here. You're being asked to comment on the problems. So here we go, problems. Okay, first off, we've got loser waterproofing. So we have to explain why that's a problem. And this means that we've got susceptible to temperature changes and affects their buoyancies. And then we've also got potentially causing damage to their internal organs. If I try and deal with all of these bits, I've definitely commented on the problems. And then it says also the actions taken to treat them. So contaminated seabirds can be cleaned by, we've got rubbing vegetable oil in and then rinsed with washing up liquid. So if I get both of those in, I've surely answered the question. So this one I actually think genuinely maybe gives me some stuff. Okay, so feathers losing their waterproofing. So waterproofing means that they need to basically repel water. So what we want here is something which is very non-polar. Because if something's polar, it will attract water. If it's non-polar, then it won't. And that would be the waterproofing. So I would probably try and explain that for a start. Okay. Next thing it says is it's susceptible to temperature changes. Now this is to do with this. So if they can't repel water, that means that the water gets closer to their body. And if it's closer to their body, then this starts to become a thing where you've got heat transfer to the water. And what you should recognise for water is this specific heat capacity is pretty high. That's 4.18 kilojoules per kilogram per degree C. So what that's doing, sorry, get rid of the -1 if I put the pairs in. Okay, so what that's saying is that it takes 4.18 kilojoules of energy to raise 1 litre of water by 1 degree C. That's pretty high. So the seabirds, which were basically not totally in contact with the water, well, not the internal bit of them, that's then getting through their feathers if you've lost that waterproofing that was repelling water from being right close to their skin where their blood flow is. Okay, so that, if you can get that, that would be nice. That would be susceptible to temperature changes. And then buoyancy, and buoyancy is the same thing. Basically the liquid in terms of the water is being repelled by the waterproofing, which therefore helps them to remain buoyant. Okay, so all of this is linked to this bit here. And then lastly it says if they swallow hydrocarbons they can cause damage to their internal organs. Now I don't know that you necessarily want to go into a lot of detail about that one, but you could reasonably say that digestion could give you toxins that you're not normally got in this. Okay, so I think if you did this, then you would definitely get enough information to have covered the comment on the problems. Actions taken. So the first thing they do is add vegetable oil. So this is oil to oil. So what they're trying to do is create a kind of mixture of oil to oil, where all of the oil is connected to the other types of oil. So the crude oil or whatever form of oil spill it is attached to the vegetable oil. And because oils will mix with oils, because they're both non-polar, then you should get a reasonably kind of nice mixture. Nice as in it's even. Okay, so what you've now got that with that mixture of oils, you then have to take the washing up liquids and explain what that would then do. So the washing up liquid is a hybrid molecule where you've got a hydrophobic head, sorry, or tail, hydrophobic end, tail it would be for the hydrophobic normally, and a hydrophilic head. And you're basically just explaining soap at this point. So if you've got a layer of oil made up of different types of oil now, because you've got your vegetable oil is all mixed in through it as well, which would be a thinner oil which will hopefully loosen it off, would I think be part of the reason. And then we bring in our soap molecule with its hydrophobic tail and its hydrophilic head. Okay, the hydrophobic tails will all latch on to the oily bits. The heads will be on the outside, and then you just rinse it off with water, and the water will pick up. So try and get a nice kind of picture of this one. We'll pick up these ones as it goes past, and as it pulls these off, they will pull off some of the mixtures of oil that are at the bottom as well. And that's how the soap works. I can't see you not getting 3 marks if you've given a reasonable discussion of some or, well, most of those points. And even if you just had a few of those points, you definitely would have to be picking up some marks in it.